For years, AI has been something we interact with through a keyboard, through a screen. But what happens when that intelligence gets a body? When it can actually step out of the digital world and into ours? That's exactly what we're going to get into today.
Welcome! Today, we're opening up the builder's blueprint for physical AI and humanoid robotics. We're going to break down how you actually give AI a physical form, how you make it move, and most importantly, how you teach it to think and act right here in the real world.
All right, first up, let's talk about a huge shift that's happening. We're moving way beyond AI that just crunches data. We're talking about an AI that can physically interact with everything around it. And believe me, this isn't just a minor upgrade. It's the next great frontier for intelligence itself.
So, what do we even mean by physical AI? It's definitely not just another piece of software. It's an intelligent system that has a body, something that can actually perceive the world around it, think about what it's perceiving, and then take physical action based on that thought process.
And this is where it really clicks. Think about a digital AI, like ChatGPT. It lives in a world of pure data, right? Physical AI, on the other hand, lives right here with us, in the messy, unpredictable real world. And that means it learns in a totally different way, not just from massive data sets, but by doing, by touching, by actually interacting with its surroundings.
This quote just nails it. This is the whole idea of embodiment. Real, true intelligence isn't just about shuffling ones and zeros. It's about experiencing the world and learning from those experiences, something a purely digital AI stuck behind a screen can never, ever do.
Okay, so if we're going to give AI a body, what's it actually made of? Let's pop the hood and break down the anatomy of a humanoid robot.
At its core, a humanoid runs on this simple but incredibly powerful loop. First, it senses the world around it. Then, it reasons about what it's seeing, hearing, or feeling to make a decision. And finally, it acts on that decision. Sense, reason, act. It's just this continuous, elegant cycle.
And here's the hardware that makes that loop possible. The robot's senses are its sensors. Cameras for sight, LiDAR to see in 3D, and even tactile sensors for a sense of touch. Its brain is a really powerful onboard computer, and its muscles, well, those are the actuators and motors that allow it to move.
Okay, so we've got the hardware, we've got the body, but a body, no matter how cool, is just a puppet without a mind and a nervous system to control it. That brings us to the digital toolkit, the essential software that really brings our robot to life.
The foundation of all this is the Robot Operating System, or ROS2. Seriously, the best way to think about this is as the robot's central nervous system. It's the universal language that lets all the different parts, the eyes, the brain, the muscles, talk to each other and work together as one.
Now, before a robot ever takes a single step in the real world, it takes millions of steps in a virtual one. Simulation tools like Gazebo and Unity are like a practice gym. It's a perfectly safe digital twin of the real world, where you can train and test the robot over and over without any risk of breaking super expensive hardware.
And inside that virtual gym, this is where the real learning happens. NVIDIA Isaac is the AI brain platform. It gives you all these powerful, pre-built AI models for the really hard stuff, like recognizing objects, navigating a cluttered room, or picking something up with just the right amount of force. It's the intelligence you load onto the operating system. Now, for what is, I think, the most fascinating part of this whole blueprint. We have the body and the operating system, but how do we give it a mind that can actually understand us?
Well, the answer is in something truly on the cutting edge: Vision Language Action Models, or VLAs. This is a whole new breed of AI, and its job is to connect the dots between what we say, what the robot sees, and what it physically does.
So here's what that actually looks like. You can just talk to it in plain English. Say something like, "Hey, pick up the red block." The VLA uses its vision to find the red block, it understands the language in your command, and then it translates all of that into the precise physical actions needed to go over and pick it up. It makes interacting with a robot feel, well, natural.
So, we have the body, we have the software, and now we have the mind. When you put all this together, you don't just see a functional robot. You see a glimpse of the future, and maybe more importantly, a clear path for anyone who wants to learn how to build it.
And this learning path shows you exactly how all those pieces connect. You start with the fundamentals, right? The robot's OS. Then you move into that safe, virtual training ground. From there, you integrate the powerful AI brain, you teach it to understand language, and then you put it all together for a final project.
And the goal of all this work? It's pretty ambitious, building a fully autonomous humanoid robot. This is where the blueprint becomes the reality, where you test every single skill you've learned to create a robot that can see, think, and act all on its own.
So, why does all this matter? I mean, besides being incredibly cool. Well, just look at where these skills are needed. Physical AI is about to completely change major industries from manufacturing and logistics all the way to assisting in healthcare. The demand is already here and it's growing fast.
And this is really the key takeaway here. A deep understanding of physical AI is not some niche little skill anymore. It's quickly becoming one of the single most valuable assets you can have for the future of technology and the future of work.
And that leaves us with one last really exciting question. The blueprint is on the table, the tools are out there, and the path is clear. So, now that AI can finally step off the screen and into our world, what are we all going to build together?